Hello students, myself is Aravind. I am working as an assistant professor in Department of Mechanical Engineering, Konkanad College of Engineering and Technology. Today we are going to see about the topic boundary layer. So boundary layer is nothing but a thin layer of fluid in the immediate vicinity of bounding surface over which velocity gradients and shear stress are large. In the image itself we have seen that the flow of a laminar and a turbulent. Velocity is 0 at the surface, which is a no slip region. So there is a boundary layer line which from surface of the object to a free stream area. So below the boundary layer the flow will be unsteady and unsteady region based on the laminar and turbulent surfaces. The variation of velocity from 0 to free stream velocity in the direction normal to the boundary takes place in a narrow region in the vicinity of solid boundary. This narrow region of the fluid is called as boundary layer. So the diagram graph shows that the curve is starting from the leading edge to the smooth flat surface and a trailing edge and has a laminar zone, transition zones and a turbulent zone, which have a laminar boundary layer and a turbulent boundary layer. In between them it has a laminar sublayer. Effect of boundary layer. Boundary layer add the effective thickness of the body through the displacement thickness, hence increase in the pressure drag. The shear force at the boundary surface create the skin friction drag. So next is development of boundary layer. The boundary layer starts at the leading edge of the solid boundary and the thickness of the layer increases with the distance along the surface. The nature of the flow changes as the boundary layer grows. This is known as development of the boundary layer. From the graph, it has been shown that the Re value will be greatly increased in between the transition boundary layer and the laminar boundary layer. So based on this we have come Reynolds number formula will be Ux divided by V. So U will be defined as free stream velocity and X will be defined as the distance from the leading edge and V will be kinematic viscosity. And the development of the boundary layer. So the boundary layer begins at the leading edge of the plate where the flow is laminar and the profile is parabolic. Due to the increases in the thickness of the boundary layer, the laminar flow becomes unstable and the motion becomes disturbed. So it will be also seen that the final layer of the boundary structure, it will be see the full turbulence boundary layer at a logarithmic profile and it has a trailing edge based on the laminar sublayer. The irregularities of the flow developed in the turbulence and the thickness of the layer increased rapidly due to the leading edge property. The short length over which the nature of the flow changes from laminar to turbulent is called as the transition zone. The velocity in turbulent zone is logarithmic. We have already seen that. Factors affecting the growth of boundary layer. The distance x from the leading edge, which will means that the thickness of the layer is directly proportional to the distance x. Also the free stream velocity is since that the thickness of the layer is inversely proportional to the free stream velocity u. And the factors affecting the growth of the boundary layer. First is viscosity of the fluid. The thickness of the layer is directly proportional to the viscosity of the fluid. And the density of the fluid, the thickness of the layer is inversely proportional to the density of the fluid, which is already seen previously. So also the final thing is when a flat smooth plate is placed parallel to the direction of the flow. The flow in the boundary layer is laminar, though the main flow is turbulent near to the leading edge of the plate. This layer of the fluid is said to be laminar boundary layer. And next thing is about turbulent boundary layer. The length of the plate is more than laminar zone. The thickness of the boundary layer increases in downstream direction due to increases in the Reynolds number. The layer becomes unstable and the boundary layer changes from laminar to turbulent. The layer continues to increase in downstream. Such layer is turbulent boundary layer. So laminar sublayer, the last thing. So the laminar sublayer is the region with the turbulent boundary layer zone adjacent to the solid surface of the plate. The velocity variation in this region is assumed linear as it is a very thin layer, so that velocity gradient can be considered as a constant thing. Boundary layer thickness. As the distance from the boundary of the solid body measured in y direction to the point where the velocity of the fluid is approximately equal to 0.99 times the free stream velocity of the fluid. So it's also seen in the diagram itself. From 0 to high value 100%, the value will be u, and for 99.9% it will be a delta value. The displacement thickness is defined as the distance measured perpendicular to the body of the solid body, by which the boundaries would be displayed to compensate for reduction in the flow rate on account of the boundary layer formation. Momentum thickness is defined as the distance measured perpendicular to the boundary of the solid body, by which the boundary should be displayed to compensate for the reduction in momentum of the flowing fluid on account of boundary layer formation. Thank you.